Hey, am I audible to everyone now? I'm extremely sorry, guys, for the technical glitch. Yeah, I know we are already 20 minutes late. All right, so let's get started, guys. All right. So, yes. So I have lots of questions from the previous sessions. Let's try to answer those questions first. Okay. So I have a question from Bhaskar that assume that the system block size is configured for 128 MB. So the client would be dividing the file example.txt into two blocks, one of 128 MB and the other of 120 MB. When we copy the example.txt, what it means by client will divide the file. We just issue the copy command, right? So yes, Bhaskar, so you're right. So we just issue the copy command. When we are issuing the copy command using so that's a Hadoop command, right? So that's a Hadoop client which will itself uh, will divide the file into two blocks. All right. So one more question. One of the question in assignment says secondary node manager takes the more memory. Why secondary name node consume more memory than resource manager node? I'm not sure about this question, what you're trying to ask, Bhaskar. Can you please rephrase the question? So we have a question from Patrick. All right, again a question from Bhaskar. You need to move a file titled weblogs into HDFS. When you try to copy the file, you cannot. You know you have ample space on your data nodes. Which action should you take to relieve this situation and store more files in HDFS? So the answer is decrease the block size on the remaining files. So Bhaskar, I know this is one of the question in the quiz which we have. Actually, the answer for this is wrong. The actual answer for this should be increase the memory of your name node. So you know that you have ample space on your hard disk. You have but you're still not able to move the file. This means that the name node is not able to make an entry in the name node memory. So you need to basically increase the memory of your name node. Actually, I've marked this question for correction. I'll inform it to the support team. Okay, so I have one more question from Bhaskar. When you try to copy the file, say 10 GB, Is the client responsibility to copy it to respective nodes, or just give the file to the master to copy it to individual data nodes? Please try to copy one file and show in the system how it gets divided into data nodes. So Bhaskar, it's not the client's responsibility. So it's just the name node. So you give the file to the master, that's your name node. Your name node will divide the file into chunks and give it to your data nodes. Again, we cannot control which file, which block goes to which data node. We can't even see it. Your name node is the one who decides it. And sure, we will be taking an example of putting a file to HDFS. So you'll get a clarity on this. All right. It's all caught up. So I have a question from Shiva Prasad. Can you please help me in accessing VM? I'm not aware how to use Hadoop VM. So Shiva, it's the detailed instructions are mentioned in the Edureka LMS. In case if you face any issues, please feel free to connect with the support team. Right? Support team would be the best one to help you in the installation and using it. Does that answer your question, Shiva? Right. I have a question from Kishore. How delta loads are handled? So Kishore, that we know, right, that Hadoop does not support appending. Hadoop supports only appending, not updating the files. So delta load would be simply a new file added to the system. So it would be handled like a regular file which you're adding. It's a totally new file. It's not the delta file kind of a thing. So Shiva has a question, where can I able to get the LMS? So it's in the login page of Edureka, Shiva. Chaitanya, I have a question. What is the command to view number of nodes? Yeah, so we will surely be seeing the commands now. We will be seeing the web UI also. So you'll get a clear understanding of it. Shiva asks, is it a PDF? Yes, it is. It is a PDF. Kishore has a question. Does Flume or Scoop segregate delta records before loading to HDFS? So Kishore, Flume does not, but Scoop definitely has something to deal with delta records. But that's a custom logic which you need to identify and you have to design that. So we can discuss this in Scoop. Yes, but definitely Scoop has something for delta records also. That's called as incremental loads. So Shiva has a question. Did you start teaching the VM? So Shiva, it is assumed that everyone would have the VM installed. Uh, I won't be teaching how to install the VM here. Yeah, so Abhilash has a question, but Hadoop does not support delta load. Yes, Abhilash, Hadoop does not support delta load. So that's a custom logic which you need to define and identify for your scoop to work. So that's basically called as incremental load. So what you basically do is you delete the previous records and add a new file. Okay. Shiva, we can basically take your questions for the VM, maybe after the class or in the breaks which we have. All right. So revisiting what we discussed till now in the sessions. So we discussed about HDFS. We discussed what is the architecture of HDFS. We discussed name nodes. We discussed data nodes. Right? We discussed what happens if a data node fails. We discussed about blocks. We discussed about replication factor, which is by default 3. Then we saw what is secondary name node, what is standby name node, what is HDFS high availability. I have a question from Kodanda Rao. I did installed Oracle Virtual Box, and there is one more Edureka VM installation. Do I need to install both of the VMs for our practice? No, Kodanda Rao, you have to just install one of the, only one you have to install, not both. Right? If your hardware is not supporting either of them, then you can simply use the Edureka cloud Hadoop cluster using PuTTY. All right. So we discussed about HDFS high availability. We discussed about HDFS federation, in which you can have multiple active name nodes in your system. Then we looked into basics of your MapReduce, basics of YARN. So let's go deep into the YARN. Right. So there are some things pending from the previous module. Let's first finish that, and then we will start with MapReduce and YARN. Right. So these were the terminal commands which we didn't see last time. We will be seeing it now. Okay. Now your Hadoop configuration files. Now, till now I have said that your Hadoop is configurable. So there are lots of properties in Hadoop, right? So all the properties are XML based, which has a property name as the XML key and a property value as a XML value. Now, almost 99% of the properties which are available in Hadoop are configurable. For example, the block size, very basic example. You can configure, you can change the block size. By default, it is 128 MB. You can change it, right? Also, the replication factor. Like if you're working with a 3-node cluster, replication factor of 3 is a good number. What if you're working with a single node cluster? What if I install a pseudo distributed Hadoop cluster? So if you remember, pseudo distributed Hadoop cluster is a cluster which has all the daemons, all the Hadoop processes running on a single machine, like your data node, name node, resource manager, node manager, secondary name node, everything running on a single machine. So in that case, what do you think? Keeping a default replication factor of 3, would it be advisable or not? Yes. So everyone says no. Can you tell me the reason why no? Why you should not keep replication of 3 if you have a single node cluster? Right. So Sanip says it takes more space. So remember, I have mentioned that your Hadoop, your HDFS guarantees you that the replica of a block will never be on the same machine. Remember my statement? Replica of a block will never be on the same machine. Correct? So if I have a single node cluster, I'll just draw it. So if I have a single node cluster, my single machine has name node, data node, your resource manager, and your node manager, right? And a node manager. If I give a file to this machine, which is a 1 GB file, which would be broken into 8 blocks, correct? Let's consider one block, block 1, right? It's a data node also, so the blocks would be stored on the same machine itself. So your Hadoop guarantees you that the replica of this block will never be on the same machine. So in this case, the maximum replication factor we can keep is 1. All right. If you don't change it, if you work with the default replication factor of 3, your Hadoop starts showing you warning. Can anyone tell me what that warning would be? Exactly. So Chaitanya gave the right answer. You have under replicated blocks. Correct. So your system, your Hadoop identifies that the replication factor you have mentioned as 3 for a file, but actually that file is placed only once. That means you have under-replicated blocks. So your Hadoop won't start taking extra space, right? It won't start taking extra space. 128 MB for a block would be taken only as 128 MB. It won't replicate if you have a single node cluster. So this also means, listen to the statement carefully, this also means replication factor should be equal to or less than the total number of data nodes in your system. Right? Replication factor should be equal to or less than the total number of data nodes in your system. So if you have a single data node, replication factor should be 1. If you have 10 data nodes, the maximum replication factor you can keep is 10. But you should not keep it as 10 because the file would be replicated. So a 1 GB file would be stored as 10 GBs. So the default values of all the properties which Hadoop has kept, they have done a lot of research on getting to the default numbers. So 3 is a logically good replication factor to work with. So if you notice, if you remember the rack awareness concept of Hadoop, they have also designed rack awareness, keeping the replication factor as 3. Right? They just deal with the first 3 replicas, and the remaining replicas can go randomly on any machine on any rack. Right? So all the design which the Hadoop team has done, the Apache Hadoop team has done, it's keeping in mind the replication factor to be 3. All right. Now all of these properties, okay, so when I say you can change the replication factor from 3 to 1, now how will you do it? Where will you do it? How do you configure Hadoop? All right. So for configuring Hadoop, there are various XML files available. Right? There are various XML files along with a shell script. So let's look at the XML files which are available. Right? So you have around 4 XML files which are available. That's core site.xml, hdfs site.xml, mapred site.xml, and yarn site.xml. Along with this, you have a shell script, Hadoop env.sh, and 2 normal text files, masters and slaves. Now let's discuss what each file contains. Okay. Now in your core site.xml, so all the configurations, right? So when I say Hadoop at core, what does that mean? So we discussed, right? Hadoop is made up of 2 different frameworks, your HDFS and MapReduce. So the properties which are common to both, right? The properties which are common to both should always go in core site.xml. A very typical example is the address of your name node. So even if you trigger a MapReduce job, right, your MapReduce will also need to know that where the blocks are present. Now how your MapReduce will know where the blocks are present? It will basically communicate with your name node, because it's only the name node who knows where are the actual blocks of your file present. So your MapReduce also requires the name node. And HDFS, obviously it requires your name node. So such properties which are common to both the frameworks which are forming your Hadoop should go in core site.xml. Now the properties which are specific to HDFS, a typical example is your block size, right? Your replication factor. This is typical to your HDFS. Such properties should go in your HDFS site.xml. Right? Similarly, the properties which are typical to MapReduce, okay, which are very specific to MapReduce, should go in your mapred site.xml. Right? Similarly, the properties which are specific to yarn should go in your yarn site.xml. So until Hadoop 1, we didn't had yarn. So for Hadoop 1, right, this yarn site.xml file was not present. In Hadoop 2, this yarn site.xml file was introduced. All right. Now your Hadoop, what is the basic environment for your Hadoop to work with? What is the basic thing your Hadoop needs? to run? Like may it be HDFS or may it be MapReduce? What is the basic thing it needs? So Chaitanya says it's Linux. Shri says it's HDFS. So Shri, I'm asking, okay, so for HDFS, what is required for HDFS to run? Chaitanya says it's Linux. Yeah, Linux is one thing. What else? Exactly. So Rahul says it's Java. So that was the first statement with which we started Hadoop, right? Hadoop is a Java framework. So for using Hadoop, may it be MapReduce or may it be HDFS, you require Java. All right. Now all of these, your data node, what is this? It's a Java process. Correct? Your name node, it's a Java process. So for starting name node, what do? You install Hadoop on a single machine and you just start the name node Java process on that machine, which makes that machine as a name node. Correct? So similarly, all of these daemons, your name node, data node, right? Your resource manager, node manager, all of these are Java processes. Now for these processes to start, it's a Java process. The basic thing which Java requires is heap size. Correct? That's the memory for that process. Now, if you, by default, every process takes 1 GB of heap size to start. Let's say you have a very huge machine. You have a machine with 64 GB of RAM. Starting a name node with 1 GB doesn't make any sense, right? If the machine is very powerful, you can start a name node with 10 GBs of heap size also. Correct? Now, how will you increase this heap size? So it's a environment property, right? So all this environment properties goes in your Hadoop env.sh. It stands for Hadoop environment file, Hadoop environment.sh. sh, it's basically a shell script. It's a shell script file. All right. Now, what does this additional files tells you? What goes in the masters and what goes in the slaves? So it's basically a text file, all right, which contains a list of machines, one per line. All right. So in masters, you specify where your secondary name node will run. Right? In the masters file, you specify where your secondary name node will run. This will be typically used in a fully distributed Hadoop cluster, where you specify one machine as a master, other machines as slave, one machine as secondary name node. So in a typically fully distributed Hadoop cluster, you use these two files, masters and slaves. Right? Your slaves, again, it's a normal text file which will contain the list of machines that run your slave. Now what includes in slave? That's your data node and node manager. So if you remember, the slave machine should run the slaves of both the frameworks, your HDFS framework also and your MapReduce framework also. That's your data node and node manager. Yeah, so Abhilash has a question, machine name as in IP address. Yes, Abhilash. So you can either mention the IP address or you can mention the host name of that machine. Both will work. Right? It should be one per line. Okay. Now guys, from Hadoop 2 onwards, all right, from Hadoop 2 onwards, this masters file is no more used. So what they have done in Hadoop 2 is they have introduced secondary name node as a property. Initially, secondary name node was started based on what was written in the masters file. What IP was mentioned in the masters file, on that IP, it used to go and start secondary name node. From Hadoop 2 onwards, they have created a secondary name node property for this. And by default, secondary name node runs on localhost. That is from where you trigger the Hadoop script. Right? The default value of this is 0.0.0.0. That also stands as localhost. So on the machine where you will start name node, on the same machine it will start secondary name node also. Right? That's a default configuration. Ideally, you should change that and you should mention a different machine, because having name node and secondary name node on a single machine does not make any sense. Then there is no question of backup. There is no question of checkpointing. So you should ideally have name node and secondary name node separate, right? Okay. Now in your Hadoop installation, okay, so Shri is asking for an example of core site. So yes, we are digging deep inside what each file contains, right? We are digging inside each XML file, right? Okay, now where these files are present. So if you download Hadoop, so the VM which you're using or the cluster which is provided by Edureka, which you will be using in case you don't have your software requirements, hardware requirements, this already has Hadoop installed. Now, in case if you want to try your hand at installing Hadoop manually yourself, so what you will usually do is you'll go to Hadoop's website, that's Apache's Hadoop website. You will download the Hadoop zip file, right? It's not a exe file or it's not a installable. It's a zip file, right? That's to be specific. It's a tar file in terms of Linux. What you will do is you will simply unzip that file. It will contain multiple folders and files. So if you know that executable files does not works with Linux, correct? It works with only files and folders. Right? So I'll just open that for you. Okay. So this is putty. So I'm using the default Edureka's Hadoop cluster and I'm connecting that using putty. So the username and password for that is Edureka. Right? So I just need to check where is Hadoop installed. Yes. Yes, it's installed here. Right? So what you usually do is you will download the zip file, you will extract it. Correct? So this is the Hadoop 2.7.0 folder which you see is the extracted version of what was available from your Apache's website. Now inside this folder, you will find multiple files and folders. Right? You will find multiple files and folders. Okay. So there is lots of garbage data present in here because this cluster is being used by multiple people, right? It's a single cluster shared across different batches, right? So you can see a lot of garbage data here, right? So your configuration file ideally goes inside this etc folder. So if I go inside etc, inside this there will be a folder called as Hadoop. So here are all your configuration files which would be required for your Hadoop cluster, may it be HDFS or MapReduce. So when I say Hadoop cluster, I'm talking about both. Right? So there are multiple files here. So we were talking about core site. So where is core site? Here you go. So if I just open this core site, right? So this is how your XML file looks like, right? So you have a XML header configuration, right, which closes at the bottom, and within this configuration tags, you have multiple properties tag. Right? So this is where you specify your properties. So you have a property tag with a name and a value, right? And this particular template, it's repeated multiple times, right? So if you look here, it's 1, 2, 3, 4, 5. 5 properties are mentioned here, right? Again, guys, this does not mean that only 5 properties are required in your core site. So there are hundreds of properties which are used by Hadoop. Whatever property you mentioned in these XML files are basically you are overriding the properties. So for example, this property fs.defaultfs, it already has a value, a default value. When you're mentioning it, that means you're changing that value. You're overriding that value. So the values which you need to override goes into this XML files. The values which you don't specify, default would be picked up for those values. So when I say, for example, just for instance, consider Hadoop wants 500 properties to be configured. This does not mean you will have 500 properties in this XML files. Only those properties which you need to change, which you need to alter, you have to mention in these configuration files. The remaining properties would be picked up automatically by Hadoop with the default values, right? So this is the property fs.defaultfs, which tells you where your name node will run. Again, so I mentioned name node is a Java process. So for every process, it requires your Linux port. For example, let's say if you install MySQL, right? If you install a database. Now for that database to start, if you want to connect to that database, you usually connect using the IP address and a port, correct? Similarly, for starting your name node, process, you have to mention a port also. So if you look here, the value, this 139.62, this is a IP on which this name node is running, and the port is 8020, right? If you want to change the port, you can change it here, right? It requires a temporary directory. So remember I told you your HDFS, right? Whatever is there in your name node memory, your name node takes a snapshot and stores it on your hard disk. Now at what location it will store, that would be mentioned by your hadoop.tmp.dir property. So whatever value you will specify for this temporary directory, your name node, your entire Hadoop will use that to use for your temporary storage. So Minesh asks, is that a default port for HDFS? Yes, Minesh, that is a default port. 8020 is the port on which your name node runs. Right? We have overwritten this property because this is not the default IP, right? This is a custom IP on which we are installing Hadoop. That's why we have overwritten this property. Right? So ideally, guys, the structure of all the XML files is the same, right? You have a configuration tag, you have property, inside which you have a name and a value tag. The same template is followed by all the other XML files. Right? So if you look at, let's say, yarn site, right? So this is your yarn site. Right? Now remember I have mentioned right? So initially from Hadoop until Hadoop 1, right? If this was your HDFS, the only guy who could access HDFS was MapReduce, right? So MapReduce was the whole and sole thing which was able to process data on your HDFS, right? So your other ecosystem tools, like for example your Hive, it used to go through MapReduce. Your Pig, it used to go through MapReduce. When I say through MapReduce, so whatever you do in Hive, it converts that to a MapReduce job, which ultimately fetches data from your HDFS. Right? Now let's say with the latest advancements in your Hadoop, you have something called as Spark. All right. Now, do you think Spark, can it go through MapReduce? What do you think? Can Spark go through MapReduce? Yes. So most of the guys says no. Shri says it's yes. Right. So let me tell you the right answer. So Spark cannot go through MapReduce, Shri. Right. Basically, MapReduce was meant for batch processing. Right. So if you have, let's say if this is your file which contains multiple lines. Right. If this is a file which contains multiple lines, what your MapReduce does is it will batch process this file. When I say batch process this file, that means it will process this file sequentially. For example, for instance, it will process the first line. All right. After processing the first line, it will go and fetch the second line. All right. Then the third line, then the fourth. So it's processing the file sequentially. All right. Now for processing every line, it is doing a disk IO. Right. Your MapReduce, this is typically what your MapReduce does. Right. For processing every file, right, every line in that file is read using a disk IO. Right. Are disk IOs slow or fast? Right. So Manish says it's slow. Patrick says it's fast. Sanip also says it's slow. Right. I have a question from Bhaskar. Is it sequentially or distributed processing? So Bhaskar, I'm talking about a single, so wrong terminology. Let's say it's a block. It's not a file. All right. Let's say it's a block. Right. So block will contain multiple lines. Right. So a file will contain multiple blocks. Multiple blocks would be processed parallelly, but each block will contain multiple lines, and each line inside that block would be processed sequentially. Right? Is it clear, Bhaskar? Great. Right. Now, disk IOs, I'll tell you the right answer. Disk IOs are very slow. Right? Disk IOs are very slow. That's why MapReduce framework is slow. Right? You cannot compare the speed at which your MapReduce is processing the data with your traditional database. For example, Oracle. Okay. Let's say you have 1,000 records. Right? Out of these records, let's say you fire a very simple query, you trigger a very simple query, select star from this table where ID equal to 100. You want to fetch the 100th row. Right? Your Oracle, it will give you the result in milliseconds. Right? Your Oracle in such queries is very fast. Right? So if your Oracle, let's consider your Oracle takes 1 millisecond, your Hadoop may take 2 to 3 minutes. Right? Your Hadoop may take 2 to 3 minutes. Yeah, Minesh says you can use indexing. Yeah, Hadoop has indexing, but so indexing is, that feature was made available with Hive. If I'm talking about core MapReduce level, there is no concept of indexing in MapReduce. Right? That's a feature which Hive is providing you. Right? Okay. Now on the other, so your MapReduce does a disk IO. Now this Spark on other hand, what it does is your Spark is a memory IO. Right? Your Spark is a in-memory processing framework. What your Spark does is consider the same problem. All right, your MapReduce was processing it line by line. What your Spark will do, your Spark will take this entire block in memory. Right? Instead of reading one line from your disk every time, it will take the entire block in memory and process everything in memory. Right? Your memory IOs are very fast as compared to your disk IOs. Right? That's why Spark is very fast than your MapReduce. All right. So the processing protocol which your MapReduce and Spark is using is totally opposite. All right. This is the reason Spark can never go through MapReduce. Right. So this was the difficulty, one of the difficulty in Hadoop 1. Right. Now what happened with Hadoop 2 is, so if this is your HDFS, right? Now the whole and soul thing to access HDFS has now become YARN. Right? And where does HDFS stands? Where does your MapReduce stands? Your MapReduce is here. Your MapReduce now goes through YARN. So your YARN, it can support MapReduce also. It can support other in-memory tools, for example, Spark also. Right? Your Pig, Hive, right? This still goes through MapReduce, right? So for example, your Hive query, it will go through MapReduce. It will create a MapReduce job. MapReduce job would be submitted to Yarn. Yarn will fetch the data from your HDFS, right? So you're getting the cycle, okay? How your data is getting fetched. So Minesh asks, are there any other memory tool? Yes, Minesh. So there is another memory tool called as Impala, right? So Impala, it has a capability that it can go this way also directly to HDFS. It can go through Yarn also, right? Okay, all right. So, okay, now if you see here, now your MapReduce, it has become a client for Yarn, correct? Now Yarn is the whole and soul responsible for accessing your HDFS, and MapReduce has become a client, right? Now for your Yarn by default does not supports MapReduce, right? Yarn by default does not supports MapReduce. To enable Yarn to support MapReduce jobs, you have to specify some properties. And where do you specify those properties? That's in your yarn site.xml. All right. And MapReduce. So MapReduce. So if you consider Hadoop 1 and Hadoop 2, in Hadoop 2, MapReduce is going this way through Yarn. In Hadoop 1, it was going this way directly to HDFS. Now, how will your MapReduce know that it should go through Yarn now from Hadoop 2 onwards? How will your MapReduce know that it should go through Yarn, not directly? So that is again a property which you will specify where in your MapRed site.xml, because that's a MapReduce specific property. You need to command to MapReduce that you cannot go through go to HDFS directly. You have to go through Yarn. That you will mention in your MapRed site.xml. Right? So if you look at the properties, so this is the property which is used as an auxiliary service. So you are commanding Yarn that you should support MapReduce. Right? So this is the property and the value which we specify to Yarn for supporting MapReduce jobs. So this is your Yarn site.xml. If you notice, it's the same template configuration with the property containing name and value. Right? And if you look at your, I think this is stuck. I will just restart this session. Right? Now, if you look at your MapRed site.xml, so this is the property in which you're commanding MapReduce that your framework now should be Yarn. Right? So it's basically a collaboration between your MapReduce and Yarn. So MapReduce says that I will go through Yarn, and Yarn says that I will support MapReduce. Right? So everything is property driven. Right? And every property has a specific file for that. All right. Now, if you look at the masters file, so masters file is also present in the same folder. I have a question. Yeah, so I have a question from Shiva Prasad that DBA will configure this. Exactly. So these properties, it is not a responsibility of developers to configure. Right? Your Hadoop administrators are the one which are responsible for configuring this. It's all infrastructure related. Right? So if you're working as a Hadoop developer, you won't even get a chance to look at these files. Right? It's all your Hadoop admins who does this. Right? So we're talking about the masters file. So if you look at masters, right? There's some garbage value here, but ideally there should be in this case, there should be a local host mentioned here. Right? Some garbage values. If you look at slaves, yeah, slaves contains the right value, local host, right? So this means the VM, the cluster which is provided by Edureka, the cloud cluster which I am connected to, that's also a pseudo distributed Hadoop cluster. Everything is working on a single node. Right? Now, how will you know that everything is running? Let's say I installed Hadoop, I started Hadoop. Okay, one more file which we missed, that's your Hadoop env.sh. So if I just open that file, so this is your Hadoop env.sh, right? It's a shell script. It's a shell script file which contains all your environment properties, right? Some things, some environment variables which you may need to export, right? Some Java settings, some heap size settings, right? All of these settings goes into this file. Right? Okay, so now let's say you have installed Hadoop. Right? Now after installing Hadoop, how do you start Hadoop? Right? So again, in the same Hadoop folder, right, where you had the folder etc, you will have two more folders, bin, and there would be one more folder sbin here. Right? So bin and sbin, this folder contains the shell scripts to start and stop your Hadoop. So let's see what is there inside bin. Right? So if you notice, these are all your Hadoop scripts available. So Hadoop is the master script with which we would be working with. From Hadoop 2 onwards, they have created specific scripts for specific daemons. So for example, HDFS. This script is created for Hadoop 2 onwards. This was not available in Hadoop 1. So HDFS, MapRed, then yarn would be one. Right? So per daemon wise, they have created individual scripts, and this Hadoop script is a master. So if you don't want to use yarn script, you can use Hadoop script. So this is basically to maintain the compatibility between Hadoop 1 and Hadoop 2. Right? So these are your usage scripts, that how will you use Hadoop. This is there in your bin folder, right? And the scripts to start and stop Hadoop is there in your sbin folder. Right? So in your sbin folder, so you have start dfs.sh. Right? So this will basically start your HDFS. Right? When I say HDFS, it will basically start your name node, data node, and secondary name node. Right? Then you will have start yarn.sh. This will start your resource manager and node manager. Right? There is one more script, start all. This will start your entire Hadoop. Right? Opposite to start, you have stop scripts for everything. You have stop all, you have stop DFS, stop yarn. Right? So all of these are available in your sbin folder. Right? Now let's say you have started Hadoop. Now how will you verify? How will you verify that your Hadoop is working? Right? Okay. So Minesh says PS minus EF. That's a typical. So Minesh, I think you're very good with Linux. Right? That's a very good way to do it. Right? You can check the processes. So there's a command in Linux called as PS, which lists all your processes running. Right? Other thing is, if you want to look at specific to Hadoop, like it's working or not, like PS minus EF will just give you the process names as Java, because may it be name node or data node, actually the backend process would be a Java process. Now, if you want to identify exactly, if you want to pinpoint that my name node is working or not, my data node is working or not, right? Now for that, right, from Java, so for this, Java 6 onwards, all right, Java 6 onwards, JDK, right, your Java JDK, it inbuilt comes with a command called as JPS, right? So this is not a Hadoop specific command. It's a JDK specific command, right? Your Java specific command. JPS stands for Java processes, right? So if you use this JPS, it will list down the names of the currently running Java processes. If I just run this, there you go, right? So if I just do JPS, so it gives you a process ID and the process name. So I have my name node running. I have my secondary name node running, node manager, data node, right? Everything, if you notice, it's running on the same machine because it's a pseudo distributed cluster. Now the other things which you see, for example, H region server, H quorum peer, your H master, these are all related to HBase, right? So the same machine contains your Hadoop cluster also and your HBase processes also, which we will discuss at the time we'll start with HBase. That's, I guess, module 7 or something. All right. Even in your Hadoop VM which you have from Edureka, you would be using this JPS command to verify if your daemons are running or not. All right. Right. So your core properties, which are common to both HDFS and MapReduce, goes to core site. HDFS properties goes to HDFS site. Yarn properties to Yarn site. MapReduce properties to MapRed site. Right. This is an example of core site which we have already discussed. We have seen HDFS site also. Now if you see, this is dfs.replication. This is the property name for your replication factor. For a single cluster, for a single node cluster, you will have to change this value to 1. All right. So Minesh has a question where we can check the logs in case of any issues. So by default, all your Hadoop logs goes into the same folder where you have extracted Hadoop, right? For example, here, like it was there in your MNT software, right? This was the folder where you have extracted Hadoop. In the same folder, you will have a folder called as logs, right? This logs folder will contain all the logs related to each and every daemon, right? For example, your data node, these are your data node logs, name node logs, secondary name node logs, right? Likewise. Okay. Now you will have a question like dfs.replication. This is a property for replication factor. How will we know what is the property for replication factor? And to be very specific, guys, this property names are case sensitive. Even a small mistake here and there, Hadoop will not consider this property. It won't throw any errors, right? If I specify any dummy property here, which is not a part of Hadoop, it won't throw any errors, but that property would be ignored, right? So if you do a spelling mistake here, Hadoop will not consider this property. So these properties are very case sensitive, right? Now, how will you get all the property names which Hadoop has, right? So your Hadoop, for example, so in your Apache's website, the default properties are already available. The default XML for each and every component is already available. Just to show you an example, I think it's there in the next slide. We'll go there first. This is your MapRed site, Yarn site. Yes, all the properties. All right. So for core site, in your Apache docs itself, all right, you have all the default core properties. If I just click here, right? So these are all the Hadoop properties which should be a part of your core site. So if you see, the list is very huge. We haven't configured everything, right? So if you see this first thing, the first column is actually a property name. The second column is the property value. Now in most of the cases, you will see default values. right? So if you don't configure the properties, it will pick up the default, right? For some properties, default values are not there, right? So these properties are very specific to security or other things which are not mandatory properties, right? If you want to see the property, the default value for your name node, fs.default.fs, I'll just search for it. See, if you see fs.default.fs, the default value is file. So basically when I say file, so if you remember the standalone mode, so Hadoop works with 3 modes, right? Standalone mode, pseudo distributed mode, and fully distributed mode, right? So this value specifies that it's working in a standalone mode, right? Local mode without starting Hadoop, right? And if you see fs.default.fs and fs.default.name, okay, there are 2 properties. Just a additional note, fs.default.fs is a property which came up in Hadoop 2. In Hadoop 1, the property which was used to specify name node was fs.default.name. Right? Now there are hundreds of properties which are used in Hadoop, right? Most of the properties, as compared to Hadoop 1 and Hadoop 2, most of the properties names have changed. Now it becomes very difficult, right, to maintain the compatibility, right? To remember the properties which has changed. So what the Hadoop team has done is, the properties which was working with Hadoop 1, for example, fs.default.name, the same property will work with Hadoop 2 also, right? The same property will work with Hadoop 2 also, but it will give you a warning that this property has been deprecated, right? Means in the coming versions, this property may no more be available, right? So the best thing about this default XML is it gives you a name and a value along with a description. So if I go to the right, there's a description available, right? So if you look at the description of fs.default.name, it says it's deprecated. Use fs.default.fs property instead. Right? So this guide is very helpful. Right? It is very helpful. Right? Similarly, you have default HDFS XML also, default MapReduce also, and default Yarn XML also. Right? Okay, so this also we have discussed what goes in slaves and what goes in masters. This file you will typically use when you will install a multi-node cluster. That's a fully distributed cluster. Otherwise, both of this file will contain a single entry that would be localhost. Right? This also we have discussed. Hadoop env. This contains all your Java-related environment settings. Right? This is an example. So if you want to increase the heap size for Hadoop, you will use this environment variable, export heap size equal to 512. Right? Export data node heap size to 128. So these are specific environment settings which you have to do in your Hadoop env.sh. Right? We have also seen JPS. Okay. Right. So most of the things from this slide onwards we have already discussed. We will quickly go through these. Right? In case of any doubts, you can stop me anywhere. Right? So name node daemon, it runs on the master node of your Hadoop distributed file system. That's your HDFS master. It directs data nodes to perform their low-level I/O tasks. Right? Data node, what is the responsibility of data node? It runs on every slave machine in the HDFS, and it is doing the low-level I/O work. When I say low-level I/O work, in terms of HDFS, it means the responsibility of HDFS for storing the files. The actual raw files is stored by your data node. So data node does the low-level I/O work for storing the files. And who commands it? The name node. All right. Resource manager, it's again a master for your data processing system. That's your MapReduce. Right. It's a global scheduler. We will discuss more about resource manager in the next module. Node manager is your MapReduce slave, right? It runs on each slave of data processing system, and it is the actual place where your data processing takes place, right? Now this job history server, guys. Now this is introduced again in your Hadoop 2. Now what used to happen in Hadoop 1 is all your logs, all right, all your logs of your MapReduce jobs was stored by your MapReduce master. In Hadoop 1, the MapReduce master was called as job tracker, right? I will discuss about this more in details. Just to give you a brief overview. So in Hadoop 1, the MapReduce master was job tracker. In Hadoop 2, it is resource manager, right? Now, when you restart job tracker, the logs which were there for the previous jobs used to get erased, right? The only logs which job tracker maintained was until it is not restarted. Once restarted, it used to clear all the logs. Okay. Now let's say I want to see the logs which was a month ago. I submitted a MapReduce job 1 month ago. I wanted to see how much time that job took, and I wanted to compare basically that how much time it is taking now. Right? So in Hadoop 1, there were no such flexibility that you were able to see the logs 1 month ago. Right? In Hadoop 2, what they did is they introduced one special machine called as job history server, which stores all your history logs. Right? So so this job history server, again, it's a special machine. Right? Again, you can have it a separate machine, or you can club it with any machine. Let's say you cannot afford additional computer, additional hardware for just job history server. So you can club job history server with any of your Java process, any of your Hadoop process. I can club job history server with name node, or I can club with data node, resource manager, node manager, anyhow. It's your choice. Right? It's based on what capacity of machine you are using. You can club multiple resources together. Right? If you notice in the current machine, if I just do a JPS, again this is stuck. So if you do a JPS, you see the job history server is running on the same machine. Right? So Hadoop will never complain that this particular daemon, this particular Java process cannot be clubbed with this one. Hadoop will never complain. It's your choice, your design, your architecture. Hadoop won't even complain if you're starting your name node and standby name node on the same machine. Right? Ideally, both should be separate, right? If name node goes down, standby can pick up. Right? Ideally, they should be separate machines, but Hadoop will never complain if you club them. Right? It's based on your architecture. Right? So they introduced job history server for serving all job history related requests from clients. Okay. All right. Now all of this Hadoop parts which we have seen, right? We have seen name node, data node, all of these. It comes with a UI, right? It comes with a user interface. Right? Now it is not a very enhanced user interface. Okay, so Minesh asks, where do you mention standby properties? So Minesh, standby is also a property of your HDFS, right? So it should go in your HDFS site.xml. All right. Okay, now all of this Hadoop things which we have seen, Hadoop processes which we have seen, it comes with a default user interface. Now this user interface is only read only, right? It cannot be used for writing to HDFS, right? For example, it is all read only kind of UI. So for example, now this UI, it also has a port, right? So this, for example, the name node, it has a web UI which defaults runs on the port 50070, right? Now, if you notice, there are two things here. Name node as a service, right? Name node as a service runs on a port which we have seen as 8020, right? In the configuration which we have seen, name node as a port, as a service runs on the port 8020, but it also has a web UI port which runs on 50070, right? So name node has two ports, one which is used for actual read and writes, and one which is used just for administering purpose, right? So this is true for all the services. The data node also has a port, right? Here, so these are all the default ports. Resource manager runs on 8088. Node manager runs on 8042, and your job history server runs on 19888. And in any Hadoop cluster, in any project you will work on Hadoop, we usually don't touch these properties, right? We usually work with the defaults, right? There's no harm working with these default ports, right? So we usually work with these ports only, all right? Now, out of these 5 things which are mentioned here, data node and node manager, the web ports for this is never used. Though it is available, we never use it, right? Because we can access these ports through your name node also. So if you log into your name node web UI, if you click on any block of data which it shows, it will automatically redirect you internally to the data node port, right? So it's an internal collaboration between your name node and data node. So you specifically, you should not, if you don't even remember the data node port, it's fine, right? But out of all the 5 mentioned, these 3 are very important. Your 2 masters, that's your name node and resource manager, and your job history, right? Make a note. Most of the cases, most of the times, it's the same value. We never change the default values for these properties, right? Okay, so let's look at these ports. Let's log into these ports. Let's see what comes up, right? So what I will do is, on the same Edureka's cluster, I will use this Edureka IP. And I will go to the port 50070. Right? So this is the port, right? This is the UI for your HDFS, right? HDFS, to be specific, name node. Right? Now, if you see, though it is a UI port, but the actual name node service is running at this port. Right? So if you see, the actual name node is running at 8020. So when your clients want to read or write to HDFS, they will use the port 8020. Right? Just for getting the health, or just for checking how many files, how many blocks are there in your system, this is the port you should use. Right? This 50070 port cannot be used for reading or writing to HDFS. This is just read only. Right? Now this gives you a lot of information. Right? This tells you when was the cluster started. Right? When was this name node started? Right? What is the version of Hadoop it is running? Right? Right? Security, it is off. Safe mode, it is off. Right? How many of you remember what is safe mode? I mean, is there anyone who does not know what is safe mode? So a gap of 1 week, right? The thing should not get erased, guys. just to quickly tell you what is safe mode, right? So remember when your Hadoop starts, so what is the startup process of your name node? It will first load the latest FS image, correct? Then it will roll the edit logs, correct? The third thing which it will do is it will get the block locations, right? It will get the block locations from where? From the data node. How? Through the heartbeats, correct? So until these three steps happen, you won't be able to read or write to HDFS. This is what is safe mode. All right. So it tells you safe mode is on or off. It tells you how many files or directories are there in your cluster. All right. And so there are 1017 files and directories. And for these many files and directories, it created 539 blocks. Right. What is the memory used? What is the heap size used? Right. So 108 MB of heap size. Yeah. So it used 45.32 MB of your heap size. Right. It tells you what is the total DFS used. Right. So almost 500, around 430 MB of your cluster is used. That's hardly 20.23%. The actual capacity of Hadoop cluster is 188 GB. Right? So it gives you overall idea that what is the status of your cluster. Guys, remember this? I told you it starts giving you warnings. This is a warning. Number of under-replicated block. See, it tells you there are 169 under-replicated blocks. This means for these 169 blocks, the replication factor has been configured more than 1 because this is a single node cluster, right? So 169 blocks did not get replicated, right? There are no over replicated blocks. In case there were some, you would have one more entry here, number of over replicated blocks, and you'll get an entry how many number of over replicated blocks are there, right? Live nodes, how many live nodes are there? So it's a single node cluster. Right? It's a single, if I just click, it's a hyperlink. If I click on live nodes, it will actually give me the IP address of the live node. Right? So the IP address which it has given is this IP address. So it's a local host. Right? Okay, so this is a data node which is configured. Right? Now if you look at utilities, so Shri asks, safe mode off means FS image not loaded. No, Shri, it's the opposite. When the FS image is loaded and when the HDFS is ready to be read or written, that means safe mode is off. Right? So so by default, when your Hadoop starts, safe mode is on. Right? When it will do this 3-step process of loading FS image, rolling the edits, and getting the block locations from data nodes, safe mode goes off automatically. Right? Now this utilities, it has something called as browse the file system. Right? Browse the file system. Now if you see, these are all the files and folders which are available on my HDFS. Right? These are all the files which are available on my HDFS. This is all view only. Right? For example, if I open this alphabets.txt, it was a file placed by someone. It's a common cluster used by multiple people. If I just click on this file, so see what information gives you. It gives you a block ID. So remember I told you each block has a unique ID, right? Which is generated by your master itself. We don't generate it. Block information, it has only one block, that is block 0. Why? Because the file size is very small. If I look at the file size is 9 KB, right? So definitely it will go as a single block, right? But you cannot see the contents of this file, right? If you want to see the contents, you need to download the file. So it gives you a link to download it. So it's all read only. You cannot upload files from here, right? So this is just for an example, your HDFS UI, name node UI, right? Okay, so let's go to this question. Which of the following file is used to specify the name node's heap size? Let's see who answers this first. Okay, most of you says it's HDFS site. Guys, remember heap size? Heap size is a Java property, right? If I want to increase the Java size, the Java heap size of name node, where it should go? It should go in your environment. It goes in Hadoop env.sh, right? It's an environment setting. It's not specific to HDFS or it's not specific to core site. It's the Java size, right? The Java size. It always goes in your Hadoop env. Right? The right answer for this is Hadoop env.sh. Right? Is it necessary to define all the properties in core site, HDFS site, YARN site, and MapRed site? Most of you says it's false, except for Bhaskar and Shri. Let's see the answer. Yes, it's false. Okay, let's see the next question to get the detailed answer for this. Standalone mode uses default configuration. Is it true or false? Yeah, that's true, right? So for standalone mode, you don't even require these files, right? Standalone mode will never consider these XML files. That's the reason. That gives you the answer for the previous question also and this question also, right? In standalone mode, Hadoop runs with default configurations, or you can also say empty configuration files. That is none of the properties mentioned in your XML files. Okay, so that's a standalone mode. Okay, now Hadoop. Okay, I have a question. Can we take break? Yeah, sure. I think we should take a break. Okay. So sorry guys, we actually we started late. That's why I kept on continuing. Okay, let's take a break. Okay, let's consider this to be a logical break. So if you have any questions, I'm here to answer those. Right? If you don't have any questions, you can have a sip of water. You can stretch yourself. You can have a break. It would be a 5-minute break. So Rahul has a question that will you show how to configure Hadoop in multiple machine? So Rahul, that's mostly a part of administrator, right? That does not comes under our sessions, but yes, Edureka provides you a entire guide on how to do that. So if you go to LMS, you will find documents for installing multi-node cluster. Let me just put a timer. So I have a question from Chaitanya. What is a Java daemon? Is it like a Windows service? So Chaitanya, Java daemon is like a process which is always running, right? It is a always running process. That's a daemon. It always runs in background. All right, guys. So I hope everyone is back. All right. Okay, guys. Now this is Hadoop. It comes with various inbuilt examples, right? So your Hadoop. So there are lots of examples, very basic examples like doing a word count or sorting a file, okay, or doing a median of a file. So like a Sudoku solver. So there are lots of basic examples which already comes in the package of Hadoop, right? You don't have to code for these, right? Hadoop already ships everything to you, right? Now, where are these available? So there, your Hadoop comes with a jar called as Hadoop MapReduce examples, and the version of Hadoop which you're using, .jar, all right? And where it is placed, it's so when you download Hadoop, when you extract it, so here, I'll just show you. All right. So if you notice, so we have seen this etc folder, bin folder, sbin folder. There is one more folder called as share. So Sanip says my audio is breaking. Is it breaking for everyone? Okay, give me a minute. I'll just. Yeah, it's better now, Sanip. Great, great. All right. Now this is a share folder. Okay. So if I just go inside the share folder, right? Share, then Hadoop, then MapReduce, right? So here there are examples, right? This examples, right? So it has lots of MapReduce jobs packaged inside a single jar file, which you can run, right? And if I just execute this jar file, okay, I think it's -h. Sorry, it's Java -jar. Mhm. Yes, right. So see how many programs it has inbuilt, right? It has aggregate word count, aggregate word history, histogram, sorry. Okay, it has db count, grep, join, lots of things, right? Terasort, Terragen, lots of things are already there. So you can just to try your hands on, just to check if your Hadoop cluster, if your MapReduce cluster is working or not properly, it's giving you proper speed or not, it's optimized or not. You can try running these examples, right? Just an additional thing your Hadoop comes with. right? So Bhaskar says, can you try running one of them? So Bhaskar will definitely be, we won't use examples, we will actually code it, right? We will actually code some of these and we will we'll run that, right? Because the examples which you just have the code ready to run, right? But what is written inside that, you don't have an idea, okay? So we will actually write the code, the actual logic, and then we will execute it. Okay, so just a screenshot, right? It's just a screenshot how it looks when it executes, right? So they have executed a TerraGen example. It generates it generates data, right? TerraGen is used for data generation. So how many rows you want, that you mention here, and you mention what is the output folder, right, where you want to store the data. Right? So this is how your MapReduce looks like when it executes. Okay, now this is checking the output. Let's see the commands of Hadoop, right? So we haven't yet seen any commands. So let's see it before going, yeah. So let's see the commands. Right? Now, as mentioned, this Hadoop script, right? But this was used in Hadoop 1, right? This is a master script, right? You can use this Hadoop script for your HDFS also, for your Yarn also, for MapReduce also. Right? What additionally they did in Hadoop 2 is they created specific scripts for HDFS. They created specific script for Yarn. Right? You can use that also. You can use this Hadoop script as it is also. Right? So if I just do Hadoop and enter, it tells me what all commands it supports, right? What all options it supports, right? So FS is the one which deals with your HDFS. So if I just do Hadoop FS, there you go. Right? So if you notice, there are lots of options available with your HDFS. Okay, there are lots of commands which are available with your HDFS. Okay, for example, so see, there is a append to file. There is cat, right? There is checksum, change mode, change owner, copy from local. There are lots of commands. Now, these commands are very similar to Linux, right? Like the command, for example, cat or chmod, chown, cp, du, df. These are all Linux commands. So this is what I meant by that your Hadoop, your HDFS, it is inspired by a Linux, right? Your HDFS, it is designed to work on top of your Linux file system. That is the reason Hadoop only and only works with Linux. It does not work with Windows. Okay. Now, okay, let's say I want to list some files. What is the command I use? I use ls, right? So if I just do a ls here, okay, I have a question from Abhilash. Do you know if it works on Fedora? Abhilash, Fedora is also a version of Linux, so it works on Fedora also. So it will work with Ubuntu, it will work with Fedora, CentOS, Red Hat, okay, any kind of your Linux system. So let's say I want to do a ls. Okay, I just do a ls. So what it did, it listed all the files which are present in my current directory. Right? This is your Linux command. I can do a ls on Hadoop also. right? I can do a ls on Hadoop also. The command for that is the same, ls, okay? But how Hadoop will know that this ls is not triggered on your Linux, it is triggered on your HDFS. So before any of your Hadoop command, right? Before any of your Hadoop command, you have to prepend the command with Hadoop fs hyphen. Hadoop space fs space hyphen, right? And then you have to type your command, for example, ls. So if I say Hadoop fs hyphen ls, this command will work on your HDFS, right? Now this is your HDFS. These files which you are seeing, these files are from your HDFS. This is not present locally, right? So for example, if you look at this file, let's say customers.txt. This is present in your HDFS. This is not present in your local file system. Now, what do you think I mean by that? Can you find this file on your local file system? Will this customers.txt be available with me on my local file system? When I say local file system, the Linux which I'm using, this Linux which I'm using. What do you think? Will it be available? Okay. So Bhaskar says no. It is on one of the data node. Kishore says before loading to Hadoop. She says not necessarily. Okay. So the actual answer is, right? So this file, you are right. It's there on your data node, right? It is there on your data node. Now, when I'm doing a ls, so what is this? This entire line which it is showing. This is the metadata, right? The file permissions. What do you think is the second column? Can anyone tell me what is the second column? Third column is the user. Fourth column is the group. Fifth column is the file size. Sixth column is the last modification date. This is the last modification time, and then the actual file name. What is the second column? Okay, so Kishore says number of copies of the file. Kishore, you're close. Isaac says it's replicas. Exactly. These are the replicas, right? So this one, second column is actually the replication factor, right? Minesh said it's a directory. No, it's not a directory. So directory, it's a directory or not? So that's visible in the permissions itself, Minesh. So if the permission starts with a D, that means it's a directory, right? If it starts with a dash, that means it's a file, okay? Now, if you notice, in most of the cases, replication is not applicable. Why is this? Why is replication not applicable for these entries? What do you think? So these are some very basic things in your HDFS. You should know this in and out, right? We don't mind if this takes time, but we should know this in and out. So Shri says those are not data files. It's there in your HDFS, Shri, so it must contain data. Okay, Kishore says local copies, no. All right. So Rahul, Saneep, Isaac, and Shiv Prasad, right? They have the right answer because these are directories, right? These are directories. Okay. So always remember, guys, directories are not replicated. I cannot break my directory into blocks, right? I can break my files into blocks. I cannot break my directories to blocks, right? So directories are not replicated. Get this very clear, right? So replication factor for directories is not applicable. Also, the size of a directory will always be 0. The size of a directory will always be 0. Though this, let's say this directory output, though this contains a file of 10 GB, but still the size of the directory will always be 0, right? Because directory does not has a size. The contents of a directory, which are files, that has a size. Okay, this is one thing. Another thing, very important, directories does not have a block size. All right, block size are only for your files, not for directories. So in this output, block size is not mentioned, right? Block size is not visible here. All right, so Abhilash says, but a directory is also a file in Linux. So there's a very small difference between a directory and a file, Abhilash. Okay, when I say, no, see, directories are listed here. The reason is directory also takes up the metadata. So directory is just a metadata entry, right? So though your directory has 10 files or 0 files, okay, size of the directory would be 0. So there are commands. So this is true in Linux also. This is same like Linux, right? If you want to see what is the actual size of a directory, okay, actual size of a directory as in the combined size of all the files which are there inside the directory, there is a command for it. Can anyone tell me, Linux experts, can anyone tell me what is the command to check the size of a directory? Yes, so Kishore says it's du. That's the right answer. So there's a command called as du. It tells you disk usage, right? So the same command we can use here. Sanip says, can we say directory is just a path to a file? Exactly, right? That's just a path to a file. That's a prefix for a file, you can say. Okay. Now block size, it's not visible in this output, right? But if you must have noticed in your 50070 port, when we saw the UI for this, when we were browsing this file system, what was the IP? I don't know why the system it disconnects so frequently. Right? So when you're browsing the file system from here, okay. Now, if you'll notice, do you have a question like, here I can see lots of files, right? There are lots of entries here, but when I'm doing it from my command line, the entries are very less and they are different. And I'll tell you why is this. Okay. Now see, your Linux, your HDFS, it is same like your Linux, right? It is much inspired by your Linux, right? Now in Linux, okay, when you create a user, right? When you create a user, every user has a home directory, right? Now, if you consider my current example, I'm logged into the with a username Edureka. So my home directory, it's /home/Edureka. Same thing applies to your HDFS, right? So for HDFS, you don't have to create users, right? Your default Linux users becomes your HDFS users. So I have a user Edureka in my Linux. The same user becomes a HDFS user also. There is no special thing required to make your Edureka user as your HDFS user. Okay, so basically it syncs with your local users. All right, so you're in HDFS, every user also has a home directory. By default, the home directory for every user is /user/ the username. Right? So in local, in Linux, the home directory is home edureka. In HDFS, the home directory is user edureka. Right? So there's a minor difference in the naming convention, but every user has a home directory. Now when I'm doing a ls in Hadoop, it by default does a ls inside your home directory. That's it's doing a ls inside /user/edureka. Right? So if I browse that through this UI, so if I go to user, see here it is, user inside this edureka. Correct? So these are the files which we are seeing from my command line also. Okay, so this is what your Hadoop does. It by defaults, it does a ls on your home directory, user's home directory. Right? Now, can anyone tell me in Linux, what is the location of your root directory? What is the location of your root directory in Linux? Okay, so Kishore says it's /. Shiv says it's /home. Shiv, it's not /home. /home is for specific users, right? The right answer is /. Okay, so Kishore and Abhilash gave the right answer. Right? Same thing applies to your HDFS. The root directory in HDFS, it's // right? So when I browsed this directory, when I browsed my HDFS, the things which are showing here, this is the root location. All right, so I can do a ls on my root location also. So if I do a ls on /, right, so I'm getting all the things which my UI is showing me. Right, now UI additionally shows you block size also, which this command line does not shows. Right, so if you notice, for a directory, right, block size is 0. Right, block size is 0, replication is also 0, size is also 0. But if you go inside this directory, there are files. Right, if you want to check the size of a directory, the command as said by Kishore, it's du. So I'll use Hadoop fs -du. There are additional options to this. -s stands for sum and -h stands for human readable /. Okay, so this does not work, so I have to give it multiple times. Right, so my root directory contains the size 431.9 MB. Okay, if I want to check the size of this file, this folder, the folder name was AN capital. Right, so it will be /AN. Right, so it is 271 bytes. Right, so it's all very similar to your Linux commands, right? So you can do lots of things here. Okay, now what is the command if I want to create a directory in Linux? What command will I use for creating a directory? Okay, so everyone says it's mkdir. That's right. So can anyone help me with the command to create a directory in Hadoop? I want to create a directory in HDFS. Okay, so Chaitanya, Rahul, Shri, everyone says Hadoop FS. All right, so Patrick Shri, you have missed the hyphen, right? So it's Hadoop fs hyphen mkdir, right? So let me use it. I'll say Hadoop fs hyphen mkdir. Okay. If I okay, just I have a question. Okay, all right. Now I want to use it. I want to create a directory inside my home directory. So if I give the name here itself, I'll give my name. Right. So the default location of this directory, okay, it would be inside /user. I'll just use a pin. Yeah. So this default location of this directory would be /user /edureka /Hardeep. Okay. Now if I okay, now instead of giving this Hardeep this way, if I give it /Hardeep, then what will happen? Where this directory would be created. Right. So Patrick says it will be created under user Edureka. No. Minesh says it will be created in local. No. So we are dealing with Hadoop commands, right? Whatever is starting with Hadoop fs, it will not touch your local. Right? Yeah. So the right answer is it will be created at the root location. So when I say root location, it would be created parallel to this user. Right? So I would be having the user folder, and parallel to this, I'll be having the Hardeep folder. Okay. Now, what do you think? Is it a complete path or a relative path? If I'm creating this folder Hardeep without a slash, it's a relative path, right? What should be the complete path? It would be /user /edureka /Hardeep. Okay. Everyone agrees this is relative or this is complete? Is this absolute path or complete path? Okay. So Minish says it's complete path. Okay. Everyone says it's complete. The answer is it is still a relative path. Right? It is still a relative path. Can anyone think about what should be the absolute path for this? What should be the complete path for this? Any guesses? What should be the complete path? No guesses? All right, I'll tell you what should be the complete path for this. The complete path for this would be, she says /home/edureka. No, she /home/edureka, that means you're referring your local Linux, right? That won't be a path in your HDFS. The complete path for this would be HDFS:/. It will start with the URI HDFS, right? After this, there would be the host and the port, right? So in our case, localhost and the port, then the path, right? This is the complete path for this file. So I'll just run this. Okay, so without errors, it came to the second line. That means the command is successfully executed, right? So mkdir. So if I'll just list it fs-ls, I have this folder Hardeep, right? Now let's say I want to put some files inside this folder. It's an empty file. It's an empty folder, right? I want to put some file inside this folder. Okay, so let's see. On my local, Okay, on my local Linux, I create a file. Okay, I create a file named test file.txt. I insert some data here. Okay, I insert some data here. I save that file. Now this test file, is it in HDFS or is it in local? Okay, everyone says it's in local. That's true, right? This file is in local. It is not there in HDFS still. Now, if I want to put this file to HDFS, right? If I want to put this file to HDFS, if I just do Hadoop FS, if you check the commands which it has, there is a command called as copy from local. Copy from local. This command is used to copy files from your local file system to your HDFS. Right? Now, what it takes a source and a destination. The best part with Hadoop commands, guys, is it is very helpful. I mean, it gives you all the suggestions. Okay, it gives you all the options. For example, I don't know how to use a command. I don't know what is the available command. So what I did is I just did a Hadoop FS. I got all the list of commands. Now I identified I want to use copy from local. So I used copy from local. The command is case sensitive, guys. Right? It's just like a Java method. Okay, C small, F and L capital. Now I don't know what options should I give to this command. I just use this command, I just enter. So it tells me how to use this. Okay, so it tells me what options it takes, minus F, minus P, minus L. That's just optional. It takes a local source and a destination. So what I'll do is my local source would be the current file that's there in my home edureka test file.txt, which I just created. And my destination, it would be user edureka / Hardeep. Any doubts in this command? I'll just run this. Right, so it comes to the next line. That means the command has been executed. Right, let's check if it went to HDFS or not. So I just do Hadoop fs-ls. Right, so if you notice, that file is inside Hardeep, so it won't show it here. Right, so I'll do a Hadoop fs-ls on this Hardeep folder. Right, so here you go. You can see the test file here. Okay, so Bhaskar has a very interesting question. So Bhaskar says you copied the file directly into some directory, but HDFS splits the file into blocks and stores it into different nodes. So that's the beauty of HDFS, Bhaskar. Okay, you will feel that you're working with a single system, right? So this command actually gave your file to your name node. Internally, name node broke this file into blocks. It gave it to your data nodes and it also replicated. That's all transparent to the user. You won't even know this is happening in the background. That's the beauty of Hadoop. So for you, it's a single file. You are dealing with a single machine. Right? It's all abstracted, all hidden from us. Right? That answers your question, Bhaskar? Yes. So Bhaskar says you just need to provide the directory. That's all. Yes. The directory or any location, right? It can, yeah, any basically directory. So Bhaskar asks, the directory is name is on master. So Bhaskar, don't get confused, right? So HDFS, so when you're creating directories, you're doing everything on master, right? creating a directory, creating a file, moving a file, deleting a file, everything which you're doing just with the master. Internally, your master will manage how to store it. Okay, so so as developers, we are least bothered how many data nodes are there in a cluster. It doesn't matter to us if it's a single node cluster or a 100 node cluster or a 1000 node cluster, right? You have to use the same command which I have used now. For now, it's a single node cluster. If my cluster is a 100 or 1000 node cluster, the command won't change. Okay, so what happened internally with this copy from local command is it copied your file to your HDFS. When I say to your HDFS, this file has now been broken into blocks, right? And it has been also replicated. Okay. Now, if I want to see the contents of this file is in HDFS. I want to see the contents. What should be the command for that? Cat, right? Cat command, which you use in Linux. The same command will work here. Right? So I'll use Hadoop fs-cat hardeep-test file.txt. Right? Hi, this is the first file going to Hadoop. So what it did is it actually contacted your data node. It got the contents of the file and it is printing on the console. So internally, now it's a single node cluster. You won't be able to, it's not doing that way. But if you imagine if it's a multi-node cluster, what it is doing internally, it is connecting through network to a different machine, fetching the lines from there and giving it to your console. That's to your client. And it's happening all transparent. Okay, that's the beauty of Hadoop. It's a very transparent system, highly abstracted. Right? Now, okay. Now, apart from this copy from local, okay, there is one more command called as put. Right? There is one more command called as put. Okay. Now, ideally, copy from local and put, right? These are the same commands. Okay. This does the same thing, vice versa. Okay. You can use these interchangeably. Now, why do you think Hadoop has provided two commands for the same thing? For achieving the same result, why do you think Hadoop has provided two commands? What is the difference between copy from local and put? Different attributes. Patrick says it's different attributes. Not really. Okay, I'll tell you the answer. Okay, it's very interesting, guys. Huh? This is not there anywhere in Edureka's contents. Okay, this comes from your experience, right? Okay, and I usually cannot keep everything to myself. I love to share my knowledge, right? So I'll tell you what happens in Hadoop. Okay. Now see, Hadoop is actually a Java API. Okay, whatever you're doing from your commands, this Hadoop fs-ls, copy from local, put, everything is basically your internally it's triggering your Java API because Hadoop is written in Java. Right? For doing this, what Hadoop did is Hadoop created a class. Okay, Hadoop API, it has a class called as file system. Right? Hadoop created a class called as file system. Now this class, so I'm assuming everyone is well acquainted with Java, right? This class is an abstract class. right? This class is an abstract class. What Hadoop did is, what the API did is, it created one class called as distributed file system. Distributed file system, I'm just writing distributed FS, right? It created a class distributed file system which extends file system, right? Which extends file system, okay? This distributed file system class can be accessed with a shortcut name, right? With a shortcut name, which is also called as URI, right? And the URI for this distributed file system is hdfs://. Okay. Now this HDFS, right? That's the distributed file system class, which is HDFS. Similar to HDFS, there are multiple file systems available, right? There is a local file system. There is a HTTP file system. There is a HSFTP file system. There are multiple types of file system. Now, if you know Amazon Web Services, there is a service called as S3. It's a storage on cloud. S3 is also a file system, right? Now, let's say I want to move my file from my HDFS to local, or let's forget about local. We have a command directly for that. Let's say I want to move my file or copy my file from HDFS to S3. Does everyone knows what is S3? Is there anyone who does not knows S3? Okay, so Isaac Karthik does not know what is S3. So S3 it's a cloud storage. Okay, it's a service which is provided by Amazon, which can store a lot of data. It's very similar to your Google Drive or Dropbox, you can say. Right? So if I want to move a file from my HDFS to S3, how will I do that? A usual way I will do is I will download my file from HDFS to local and I will put it from local to S3. Right? Now to make it compatible, what Hadoop did is, Hadoop created multiple file systems. So when it says it's kind of similar to FTP, no, it is not similar to FTP. It's a separate thing. It's a cloud storage kind of a thing. All right. Now what Hadoop did is Hadoop created multiple file systems. Okay. So just to name a few. Okay. Just to name a few file systems. So the first one is distributed file system. This is the class, right? It created one more class, S3 file system. It created one more class, HTTP file system, right? HSFTP file system. Then your local file system, right? And there are many file systems. Okay, there are lots of them. Okay, lots of them. What Hadoop did is all these file systems inherits from this. What's happening? Yeah. Okay. So all of these file systems extends file system, right? All of these file systems extends file system. What is file system? File system is an abstract class. Now, if you consider simple Java, okay, simple Java, I have a class A, I have a class B which extends A, I have a class C which extends A, I have a class D which extends A, right? Everyone has the same parent. This means this B, C, and D are compatible with each other, right? Because they have the common parent. The same logic Hadoop is using. Hadoop created a class file system and it created multiple implementations of this file system class. Due to this, what happened is all these implementations became compatible, right? So the Hadoop command which you are using, right? You can use it with HDFS also. You can, same command can be used for S3 also. Same command can be used for local also. Same command can be used for HTTP, HSFTP, and there are multiple. There are around 20 implementations of file system, which is done and given by Hadoop ready-made. You are not doing anything special for it. Okay, just to tell you an example. So how will my command identify that this particular file location is not HDFS, this is S3? Or how it will identify this is not S3, this is local? That is all based on shortcut names. Okay, that's also called as URI. So for distributed file system, which is your actual Hadoop class, the URI is HDFS:/. For S3 file system, the URI is S3:/. For local file system, the URI is file:/. Okay, so just you change the URI, the entire internal implementation will change. Okay, I'll give you a demo of that. So it's not there in the slides, it's not there in the any recordings also. I'll just give you a demo. It's again stuck. I'll restart the session. Okay, for example, I'm doing a Hadoop fs-ls on or I'll do a cat, give you a clear understanding. Right? So this is what we have seen. Okay. Now I have put this file from my local itself, right? It's there in my current location also. That's if I do a cat here /home/edureka/test_file.txt. This is the original source location. Right? And I've used a cat command for this. I have not used Hadoop fs-cat. What will happen if I do Hadoop fs-cat? What will happen in this case? Can anyone tell me? If I do Hadoop fs-cat and I give this path, home edureka test file.txt, that's my local path, right? What this command will output? Will it print the contents? So Minesh says it won't find the file. Everyone says no. That's the right answer, right? It will say file not found. It will say file not found. Okay, no such file or directory. Why is this? Because Hadoop fs command always looks for your HDFS. Correct? And this file is not in HDFS. This is in my local. Right? Now just see the magic here. I give the complete path now. I use the URI file:/. File URI stands for local, right? So if I use this URI and check the beauty, it is now printing it. The internal implementation with the same Hadoop command has changed from HDFS to local just by using the URI. That is what I meant by all your Hadoop commands are compatible with each other. Not the Hadoop commands, basically the paths, right? The path of the file or directory, it's compatible with each other. By just changing the URI, the entire implementation will change, right? So they have made Hadoop commands very compatible with all the file systems. Manish is asking, just for info, hyphen, is this in Hadoop 1 as well? Yes, Manish, it's there in Hadoop 1 as well. Okay, now I'll tell you a very typical use case. Where are we using this magic of Hadoop? Okay, so what we usually do is, so we, so the client, so I told you, right? So one of a client, right? One of a project basically, we get data every week, right? The data is around, so there is different for different projects. For one of the projects, the data is around 700 GB, right? 700 GB per week, we are getting the data. And this data is compressed. It's a gzipped file, right? Multiple files combined, it is 700 GB, right? Now the client provides us this data on S3, right? We get this data from S3. What client does is, client gives us the path of this data and the actual, so for accessing S3, you require secret key and access key. That's an Amazon specific thing for accessing S3, right? So client gives us the secret key, it gives us the access key, and it gives us the path of the files. Now what we do is, so in this particular project, so just give me a minute. All right. So for processing the 700 GB of data, we launch a Hadoop cluster, right? Now this Hadoop, so Hadoop cluster, so when we say, so we are, so this particular project we are doing only with Amazon, right? Only with cloud. So Amazon, when I say it provides you a storage on cloud, it provides you multiple other features also. It provides you a Hadoop cluster on cloud. That's called as EMR. It's a service of Amazon. It stands for Elastic Map Reduce. So what we do is, so we launch a 20 node cluster. Okay, we launch a 20 node cluster. 20 node means 20 machines, and Amazon charges you per machine per hour. And the machine which we use are very heavy machines. Each machine has a RAM of 256 GB, and each machine has 64 cores of processor, 64 virtual cores of processor. So it's a very expensive machine, it's a very heavy machine. All right. So what we do is we launch 20 such machines. After launching 20 such machines, after the Hadoop cluster is ready, it takes around 20 minutes to spin up the Hadoop cluster. All right. Now with Hadoop command, so Hadoop, we copy everything from S3 to HDFS. All right. We copy everything from S3 to HDFS. Now to do this faster, Hadoop created a command called as distcp. I'll just type it here. Hadoop created a command called as distcp. It stands for distributed copy. Right? I'll discuss about this distcp in the coming sessions. All right. Now with this distcp, we copy everything from S3 to this newly launched HDFS Hadoop cluster basically, HDFS. All right. We process the data here in Hadoop, which takes around 2 days. Right? The processing takes around 2 days. After the processing has been completed, the processed output, we put it back to S3. Right? The processed output, we put it back to S3 again using the same distcp command. Why this is possible? Because S3 and HDFS are compatible in point of view of your Hadoop. Once the processed data is back to S3, we terminate this cluster. So overall, the cluster which we use is used only for 2 days. That's almost 48 to 50 hours. Why we don't keep the cluster always running? Okay, so Bhaskar says, can you please explain? Okay. So Bhaskar says the compatibility of S3 and HDFS. So the same thing, Bhaskar, which I explained. The same thing, that file system is an abstract class. which has multiple implementations. HDFS is one of the implementation and S3 is one of the implementation. So HDFS and S3 has the same parent class, that is file system. And both of these classes are provided by our Hadoop itself. All right. So instead of using, let's say I use a location slash user slash XYZ. By default, your Hadoop will consider this to be a HDFS location. If I just add S3 colon double slash in the starting, right? This location will now become a S3 location. The entire implementation for the same Hadoop command where it was referring to HDFS, now it refers to your S3. Right? So what this CP, how we use this CP is, right? We use a DistCP, DistCP from S3 to HDFS. And this DistCP is a Hadoop command, right? This DistCP, it's a Hadoop command, right? In Hadoop command, we are providing a location of S3. How that is possible? S3 colon double slash and the path. And the destination is HDFS colon double slash then the path, right? After the processing is done, the processed data, we put it back to S3. Again, the same command, just the source becomes HDFS colon double slash and destination becomes S3 colon double slash. Same command untouched would run in both the cases by just changing the URI. That's the beauty of the compatibility which Hadoop provides. So Chaitanya says, is S3 also one more Hadoop? No, Chaitanya, it's not Hadoop, it's a file system. Like you have a local file system, you have a Hadoop file system. S3 is also a file system. And your Hadoop provides an implementation to access S3. Right? So with the same command untouched, processed data, we put it back to HDFS after 2 days and we shut down the Hadoop cluster. Why? Just to reduce the cost. Keeping the Hadoop cluster up and running 24/7 does not make any sense because this data we get every week. Every week the processing we take is 50 hours, 48 to 50 hours. Only for that time we keep the Hadoop cluster on and then we terminate the cluster. So I have a question. S3 is Amazon product. Yes, Kodandarao, it's an Amazon product. Hadoop gives an implementation of S3 file system also. So Hadoop gives you lots of things. It's very helpful. Okay. So again, so this happens every week. Every week we launch a new cluster, 20 node cluster, process it for 2 days, keep the data back to S3. The clients use it for reporting from S3 itself, and we shut down the cluster. Initially, how we used to do it is, we used to do it in Teradata. Right? Teradata used to take 7 to 8 days to process the same 700 GB. So we have reduced the processing time from 7 days approximately to 2 days. Also, we have cut the cost by more than half. Right? We have cut the cost. So it's very helpful. I'll again discuss a few things about this project once we discuss DistCP. Right? So you can see the beauty here itself, right? Just by changing the URI, I'm able to read my local file also. Initially, which it said no such file or data. Okay, so Kondandara has a question. We are copying the content from S3 and processing in Hadoop. Why we are copying from HDFS to S3? I mean, S3 already has the content, right? So Kondandara, processing is done in HDFS. Processed data, we keep it in S3. Right? So 700 GB of data, raw data, when processed, the output is around 20 to 30 GB. It varies from 20 GB to 100 GB within. So that processed data, we keep it back on S3, and on that processed data, client creates reports, right? Okay, so going back, all right. The output of MapReduce job will be stored on HDFS. It's true or false? So Rahul has a question. In S3 we cannot process data. So Rahul, S3 is just used for storage. It is storage on cloud. It does not gives you any processing power. For processing we use Hadoop. So Patrick says, what were you processing then? So Patrick, the data is all your pharma data, all your sales representative data. So basically we run a very complicated rules engine where we calculate uh, what compensation should be given to each sales representative. So it's all sales and crediting kind of a tool which we are processing, which we are doing. All right. So output of MapReduce job will be stored on HDFS. We haven't discussed MapReduce yet, but I'll tell you the answer. It is true, right? It is stored in different files. So I'll discuss this when we'll discuss MapReduce. To run MapReduce job, data should be present on HDFS, right? I'll tell you the answer for this also because we haven't discussed. The answer to this is true as per Edureka's content, but it is false, right? The actual answer is false. I can run a MapReduce job directly on S3 or any file system using my HDFS processing because Hadoop is compatible, right? I can actually trigger MapReduce code, right? My MapReduce job on the data which is not there on HDFS. It's there on any compatible file system of Hadoop. It can be local, it can be S3, it can be HFTP, HSFTP, anything, right? Okay. So Manish says it will be too many IO. Yes, it will have lots of IO. See, the fastest would be data when it is there on HDFS, the processing would be the fastest. But when it's there on S3 and I'm doing a MapReduce job on S3, it will use a lot of network IO and a lot of disk IO also. Right? So it would be slow, but yes, it will process it. It will not fail. It will run. Okay. So this is an overall data loading technique and analysis technique which you do in Hadoop. All right. I'll just use a highlighter or spotlight. Yes. All right. Now, HDFS is your central. Okay. Now, for bringing data to your HDFS, there are lots of loading techniques available. The one which we saw, the Hadoop copy commands. All right. Then there is something called as scoop, and there's something called as flume. Okay. So Sanip has a question. You said S3 is just for storage. How it is capable to process? So that's the power of Hadoop, Sanip. What happens is when you provide a S3 path for a MapReduce job, internally, very transparent to the user, what Hadoop will do, Hadoop will download everything to your HDFS and then process it. That's a long cycle, traditional cycle which your HDFS will follow. But from a developer's point of view, you can write a command to process data on S3, right? So for developers, you will get a feel that the data is getting processed on S3. Right? So Bhaskar says MapReduce will not process on S3. No, MapReduce will not process on S3. Ultimately, it's processed on HDFS, but a path of the file can be on of a S3 path or a local path. Okay. Now there are multiple tools available in your Hadoop ecosystem which fetches data for you, right? We have seen. So there's a tool called a Scoop. What it does is it pulls all your RDBMS data to your HDFS. Right? We have a discussion on we have a module for Scoop, a discussion on Scoop, not a module. And Flume is used for fetching all the streaming data to your HDFS. For example, your Facebook likes or your Facebook comments or your website logs, right? These live data which you want into your HDFS, we can use a tool called as Flume, right? So there are multiple techniques to load data to your HDFS. And for processing data, you can use multiple data analysis tool. There is Hive, there is Pig, then there is core MapReduce, that's your Java level MapReduce. There are multiple things for data analysis. This is a typical way how your Hadoop works. What we usually do in Hadoop. Right? Yes, so Hadoop copy commands, which we have seen. Here comes distcp. All right. Now, some additional things about distcp. Right. Now I'll tell you what is the need of distcp. This is also not mentioned anywhere. Okay. Now let's say I have a Hadoop cluster. Very interesting thing, guys. Huh? It's like if you're going for a Hadoop interview, if someone asks you about distcp, if you can tell him in this much details, you will be definitely selected. Right? Let's say this is my Hadoop cluster. I'm talking about HDFS, so I'm just showing name node and data node. I have a file.txt, which is 1 GB. All right, which will have 8 blocks. I'm drawing 8 blocks. 1, 2, 3, 4, 5, 6, 7, 8. All right. How will your HDFS store this file? So we have discussed this earlier. I will quickly explain you. So I'll just number it 1, 2, 3, 4, 5, 6, 7, 8. So what your Hadoop will do, what your HDFS will do, it will take the first block, give it to any data node, and data node will replicate. Right? When this replication is done, when this block has 3 replicas, then your Hadoop will pick up the second block, give it to any data node, and then it will replicate. Then it will pick up the third block, data node, replicate. What it is doing here, it is writing your blocks sequentially. Right? When one block is replicated thrice, only and only then the second block would be picked up. All right. So Patrick has a question, who breaks the block? It's your name node who breaks the block. Right? Bhaskar has a question. Yes, Bhaskar. Right. So Bhaskar has a question. Copy will happen parallelly, right? No, Bhaskar. Copy will happen sequentially. Copy will. So I told you, writing in Hadoop is very slow. Hadoop is very fast for reading. All right. Writing is sequential. It will pick up the first block. All right. Create 3 replicas, then pick up the second block. Right. Second block, it will create 3 replicas. Until 3 replicas are created, third block will never be touched. When the second block is replicated thrice, then it will touch the third block. Right? So for every block, writing 3 copies across network to different machines and then picking the second block, that's why writing takes time. Writing is slow in Hadoop. Yeah, so Jayesh has a question. Why can't it process 3 blocks parallelly since 3 nodes are available? Is there a parameter? Sanip says replication is parallel process or not? Replication is not parallel, right? And Jayesh, to answer your question, this is how your Hadoop, your HDFS is designed, right? It will not do it in parallel. There is no parameter which can make it parallel. right? There is no parameter. Hadoop will by default write it sequentially only. There is no property to tune this thing, right? Let's say I am writing a 1 TB file which has say 5,000 blocks for an example. Imagine how much time it will take to write 5,000 blocks with replication factor 3. It would be very slow, right? Now, in such cases, Hadoop identified this problem, right? Hadoop knows that this is a problem with it, okay? Now, what Hadoop did nothing. I mean, HDFS did nothing to solve this problem. It totally relied on your MapReduce. So Bhaskar says slide 44 and 45 in first class says writes are parallel. Bhaskar had mentioned that time also that slides are wrong. Okay, writes are always sequential and slow. Right? I had specifically taken told a note there. Okay. All right. Now Hadoop identified that writing is slow in Hadoop. So HDFS did nothing for this. All right. Who did it? It's the MapReduce. So we know, right? MapReduce is a massively parallel framework. So what Hadoop team did is they developed a tool, and that tool is distcp. Right? Now what this tool does is it can make your write parallel. Right? Distcp can make your write parallel. Guys, one more. So thing to note here is distcp is a MapReduce tool. It's not an HDFS tool. So HDFS did nothing to make your writes parallel. It's your MapReduce who did it. So what distcp does is distcp takes multiple blocks together, where your HDFS takes one block and writes it, replicates it, then picks the second block. Distcp takes multiple blocks together and writes it, starts writing it parallelly. That's what distcp does. Okay, a typical use case for distcp is, let's say I have one Hadoop cluster. Okay, let's say I have one Hadoop cluster which contains, let's say, 100 TB of data. Right? I want to create a backup of this 100 TB on a separate Hadoop cluster. I have one more Hadoop cluster, backup cluster you can say. I want to take a backup of this 100 TB. In such cases, I will use distcp. Right? In such cases, I will use distcp. Okay, so Bhaskar has a question. Sorry, confused. MapReduce job is to process. Why it copies? Okay, so Bhaskar, MapReduce gives you a capability of doing the things parallelly. It can be either processing, it can be either copying. So what they smartly did is they created a tool such a way that it assumes copying as a part of process, right? And to make your copying parallel, okay, it basically designed distcp. Right? So ultimately, if you look in terms of your MapReduce, it is processing. But if you look in terms of your HDFS, it is copying. Right? So they have clubbed the copy part as a processing thing. Right? The only thing they developed distcp is to make your writes faster. Okay, and by discussing so much of things, I just missed one point. I left one point in half. The difference between copy from local and put. Right? The difference is copy from local. Right? It can only copy from local to HDFS, as the name says, copy from local. But put, it can copy from any Hadoop file system to any Hadoop file system. Right? That's what triggered the discussion about the file system abstract class. Okay, so put can be used for S3 to HDFS, HFTP to HDFS, HDFS to S3, any file system. That's why that's a difference between copy from local and put. right? Now, so this is a typical use case of disk CP. Disk CP is used for inter-cluster transfer, right? This transfer would be fast. See, you can do this transfer using put also, correct? In the first case, I'll give the URI of this cluster, the IP of this cluster. In the destination, I'll give the IP of this cluster using the put command. This will still work, but this will take months to copy 100 TB of data, right? With disk CP, because why? Because put is a HDFS implementation. HDFS implementation is meant for writing sequentially. That's why put would be very slow. Disk CP, it's a MapReduce implementation, which is parallel. That's why in such scenarios, you will always use disk CP. It stands for distributed copy, right? It's a typical use case, okay? But it can be used in other ways also. So if you notice here, can anyone tell me, let me restart the session. Hadoop has a command CP. It has also a command, also has a command MV. Why this CP and MV is used? CP stands for copy, MV stands for move. Why do you think these commands are there? What special CP can do which your copy from local cannot do? Rahul has the right answer. From HDFS to HDFS. Okay, so the answer is in a same cluster. Okay, if you look at this, right? I have a test file inside Hardeep folder. What if I want to copy this inside my root folder? It's the same cluster. Okay, if I want to copy or move this file from Hardeep to my user edureka folder, I will use CP and MV. So we are moving within the same cluster, right? Moving or copying within the same cluster. Okay, so in such cases, if you're using copy, still it will be very slow because copy is creating a duplicate copy, right? It will create as many blocks as your original file, as many replicas. So it will be slow. In such cases also, you can use disk CP. So disk CP can be used for inter-cluster and intra-cluster transfers. All right. In such cases also, you can use disk CP. Right. If I just say Hadoop and enter, see, here is the command, dist CP. Right. Okay. A very logical question. Let's see who can answer this. Let's say I have a file of 100 TB. Okay, I have a file of 100 TB in my folder XYZ. Right? move. I try to move this file to my folder ABC. How much time this will take? Approximately how much time this will take? I'm trying to move, I'm not trying to copy. Any answer? So Rahul says days. Patrick says lots of time. Minesh says less than 10 seconds. Right? The right answer is it will be in milliseconds. Right? It will be in milliseconds. Now, why so fast? It's a 100 TB file. Why so fast? What is changing? What do you think? What is changing? Moving a file from 100 TB to 100 MB. Moving a file from 100 TB to 100 MB. What is changing? 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 What is ch from this location to this location, is it touching my blocks? Is it creating duplicate blocks? Is it moving my blocks? No. It is just updating your name node metadata. It is just updating your name node that the location has changed from this to this. And where is that metadata? In your name node memory. Memory as in RAM. Memory IO is extremely fast. It will take milliseconds to move. Right? It will take millisecond to move. But when you say copy, it is creating duplicate, it is creating 100 TB more, right? 100 TB, that's 300 TB, right? It's with replica. That will take days, right? So always remember, copy is very slow, move is extremely fast, because move is just a metadata update. Metadata is there in your name node memory, and memory IO is very fast, right? So we'll quickly, we are above time, we'll quickly try to wrap this. Okay, so Rahul has a question. Move from local to HDFS is possible? Yes, Rahul, it is possible. So if you just look at the Hadoop commands listed here, okay, so it has lots of commands. It includes copy from local also. It includes move from local also. Move from local, right? There is also opposite command, copy to local, right? This will copy from HDFS to local, right? Similarly, there is move to local. And similarly, there is opposite to put, get. All right. So copy from local is similar to put, copy to local is similar to get. All right. Okay. So demo on copy commands we have seen. Data loading using Flume. So this is just an example. We have a demo for this, which will be covered in the last module. So we can basically, as I mentioned, it can be used for getting your data from any social network, right, to your HDFS, right? So your Flume basically works as three components, right? The first component is called as source, second component is called as sink, and third component is called as channel, right? So Flume has multiple types of sources, multiple types of sinks, multiple types of channels, right? The example which is shown in this slide, the source they have used as a Twitter source, sink they have used as HDFS, and channel they have used as memory. There are other options also available, which we will see when we look at a demo of Flume. Similarly, scoop, right? So we've already discussed why scoop is used for, right? And how we can use scoop. We have a demo of scoop, which we will cover in module 10. Okay. Okay, your website is hosting a group of more than 300 sub websites. You want to have an analytics on the shopping patterns of different visitors. What is the best way to collect this information from the weblogs? Is it using Scoop or Flume? Right. It's a quick answer from everyone. It's Flume. Oh, Shiv Prasad says it's Scoop. Isaac also says it's Scoop. So difference between Scoop and Flume is used for getting streaming live data. Scoop is used for moving data from your traditional database to your HDFS. All right. Weblogs, the question says, what is the best way to collect the information through weblogs? Weblogs is streaming data, continuously generated data. It is not structured. It is unstructured data. Scoop can only work with structured data because Scoop can only work with databases, traditional database. Right. So the answer here is Flume. Right. You want to join data collected from two sources. One source of data is collected from database of call records is already available in HDFS. The another source of data is available in a database table. The best way to move this data in HDFS is Scoop, Pig, or Hive. Now here the answer is Scoop, right? Because we are dealing with database, moving from database to HDFS, we use Scoop, right? Okay. So the assignment for you, right? Go to Edureka's VM and explore it. Check working condition of Hadoop ecosystem. Check is your Hive, Pig, and everything is working. I missed a question from Rahul. Move from local to HDFS, does that also takes milliseconds? No, Rahul. Move from local to HDFS does not take milliseconds. Because though you are moving from local, but still you are creating an HDFS, right? That does not take millisecond. That will take equal time as copy, right? Because it needs to create blocks and replicate, right? So move from local does not take milliseconds, right? Sorry to answer that late, right? So we have links for further reading. Please go through it. All right. So tomorrow's session would be practical session. We would be coding for MapReduce, right? We would see how MapReduce works. What is yarn, right? We have it here. Agenda for next class, right? We'll see use cases for MapReduce, which we have discussed already. Actually, we have seen that we will see traditional versus MapReduce way. We will see Hadoop 2 components. That's what is yarn and how the data is flowing in yarn, and we will see MapReduce concepts. Okay. I will try my best to take the practical sessions also tomorrow, but let's see. I mean, if the uh, MapReduce flow is taking time, then we can move the practicals to the next weekend, right? But MapReduce, it's very important. The data flow is very important, right? So we will look at the data flow of MapReduce tomorrow. And I'm extremely sorry, guys, for the technical glitch which we faced in the starting. We lost 20 minutes there, right? Also very important, please fill in the survey. Please give your feedback. It is very important. Okay, may it be a compliment or suggestion or a complaint, right? Please spare some time and give your feedback, right? Thank you, guys. Thanks for being so patient. Right, so I have a question from Kodandara. Is there anything extra customized in Edureka VM than Oracle VirtualBox? No, it's the same thing, Kodandara. It's the same thing. Thanks, everyone. So I'm still up for another 5 to 7 minutes. If you have any questions, you can discuss them. Right? Others, if you don't have any question, you can drop off and fill in the survey, of course. Right. So I guess someone was facing issues in installation of VM. So we can discuss it right away now. Rahul, so he asks that can we override HDFS process to use this CP? Not exactly, Rahul. HDFS is already developed. So as mentioned, right, HDFS is a separate framework and this CP is MapReduce is a separate framework. So as MapReduce has already provided the implementation, we cannot replace it. Jagan has a question. Do we use any tools to load data to Hadoop? Yes, definitely we do. DisCP is one of a tool which we use. Then we use Scoop, Flume. These all are the tools which we use for loading data to Hadoop. Okay. So Shiv Prasad says, I have installed it, but not aware of how to work on VM. So VM is just like it's a virtual machine, right? It's a OS on top of your Windows. It's a Linux on top of your Windows, right? So it's how should I explain you this is? Mm, it's a normal. So you have experience on working on Linux, Shiva Prasad? Oh, so I have a question from Kodanda Rao. When I click on Edureka VM installation download link, it throws an error. Uh, can you just contact the support team, Kodanda Rao? Because I recently downloaded it. It worked for me. It's a 4.5 GB file. Okay, so Shiva says not much, no basic commands. Yeah, Shiva, that's fine. I mean, basics for now, it's okay. There's not much issues. In the guide which they have provided, Edureka has provided, they have given every step very detailed, like how to use the VM, how to troubleshoot, how to check if Hadoop is working or not. And when you start the VM, on the desktop itself, you have a README file, right, which tells you most of the details. Kishore asks, should we concentrate on Scala and Spark also? So depends, Kishore. See, as a fresher to Hadoop, if you're going to a company, it's very less chances that you will directly work on Scala and Spark because it's a very highly advanced thing in Hadoop, right? So if you know basic Hadoop, right, core Hadoop is important for Spark. HDFS, MapReduce, Yarn, these things are more important, right? Once you know these things, then definitely you should concentrate on Scala and Spark, but maybe not in the start phase. I know that's the next generation of MapReduce. You should be knowing it, but yeah, but at this stage, concentrate on Yarn and HDFS. Okay, Chaitanya asks how to know PWD in Hadoop, the current working directory. Current working directory in Hadoop, Chaitanya, will always be your user's home directory. So if you're logged in through your user, let's say Chaitanya, the current working directory would be /user/Chaitanya. Right? There is no command like pwd in Hadoop. We can practice in Oracle VirtualBox instead of Putty. Yes, Kudandaro. I mean, it's definitely better to practice on VirtualBox instead of Putty because Putty lots of people are using. There is lots of data there. Okay. In fact, I am also facing some challenges in VirtualBox because it's my corporate laptop and I'm not able to install additional softwares here. So I'm not able to connect to internet through my Oracle VirtualBox. So Rahul has a question: to clear Hadoop certification, is Spark required? So if you're doing it from Cloudera, Rahul, it is required. So from this year onwards, from 2017 onwards, they have changed the pattern. They have made Spark mandatory. Okay. So for clearing Cloudera certification, you should know Spark, but it won't be a very difficult use case for you to solve. It would be basic. Spark would be basic. The best thing is Cloudera is now providing you with all the, so it has made internet available to you. Like, so they will give you 5 use cases, and use cases you can use Hive, Pig, HPay, Scoop, Flume, all of these frameworks you have to use, all of these tools you have to use. And the best thing is Apache's link for all these, the user guide for all these tools, you can browse. Right? You can basically Google for, I mean, it's open. Okay, so if you're facing challenges how to use Spark, you can go to Apache's website. In course, between your certification, you can go to Apache's website, browse through the user guide of Spark and use it. Copy paste the commands. That's they have allowed. When I had done my certification, it was mostly practical MCQ based. I did it 2 years back. Right? So I hope you have filled your surveys. So let's disconnect. Right? So we'll meet tomorrow, same time. Good night, everyone.